think about the concept of thermal equilibrium. Assume you have two blocks of the same material. One is at a cold temperature and one is at a hot temperature. Currently, they're not in thermal contact, which means no heat can transfer between the two. Let's say we now bring them into thermal contact with each other, so now that heat can transfer between the two blocks. What will happen? Well, you know from experience that the cold block will become warmer and the hot block will become cooler until they reach some middle temperature, which we'll call TEQ. This is the equilibrium thermal temperature that is in between the cold temperature and the hot temperature. Now let's say we have the same two blocks of material and then we have a third block in between them to help them make thermal contact. Well, we can do the same type of process with this third block in between. Indeed, all of the blocks will come to the same final temperature, this TEQ. And even if block B is made out of some different material and it can either transfer that heat very fast or very slow, which we'll talk about more for Wednesday's class, how that happens. But even if that is slower or very fast, that heat transfer through, at the end, when they're in equilibrium, they'll all be at the same temperature because that is actually the definition of thermal equilibrium. And no more heat will be transferred between them. So in thermal equilibrium, the temperature of block A must equal the temperature of block B. Further, the temperature of block B must equal the temperature of block C. And by the definition of equality, then that means that the temperature of block A must equal the temperature of block C. This seems like a very pedantic thing to say, but all of this comes together in the zeroth law of thermodynamics. And so what this says is that if system A and system B are in thermal equilibrium, and system B and system C are in thermal equilibrium, then system A and system C are also in thermal equilibrium. This is basically just saying that all the temperatures are equal, but that no heat can transfer between A and C any longer as well. The corollaries of this are that all the blocks are at the same temperature, and there is no heat transfer between any parts of the system.